Okay, we'll wait a few minutes for other people to join. Hello, everyone. Today we're going to talk about load testing with HeadSpin. Skip to the next slide there. My name is Aaron Gibson. I'm a software developer here at HeadSpin. I work primarily on back-end stuff. I've worked on single sign-on, and I've worked on other infrastructure-related stuff. And today we're going to talk about load testing and how, at HeadSpin, how we use load testing to help better understand how we can improve app development for our users and customers. So we're going to talk quickly about load testing with HeadSpin, what we support and offer. We're going to talk about playbooks, which are the main, sort of the dominant aspect of load testing. Basically, playbooks are the script that you, or a set of scripts, if you will, that run on the different targets and simulate the load. And then we're going to have a demo to show how this all plays together. Both we can schedule tests, we'll demo running a test, we'll demo how this integrates a little bit with the performance monitoring UI as well. So the main question here to start with is like, why would we load test? I think most of the time developers get caught up in stuff like unit testing and integration testing and smoke testing, and these are extremely important, and they verify the functionality of an app. They verify that the app behaves as expected. They verify that, you know, the user expected input results in expected output. But in real life and when you actually deploy an application, a lot of things that get overlooked are what happens when multiple users hit the system at the same time. And, you know, maybe one or two users or a couple users is not a big deal, but what happens when a lot of users hit the system? And how does this affect the server backend? And so maybe the server stops serving as many requests per second because it's bogged down, or maybe, you know, maybe the server just doesn't respond quickly and there's connectivity drops, especially in the mobile application environment, and so on and so forth. And at HeadSpin, we're concerned with how the server load might integrate with the user experience. So load testing produces metrics that are valuable in its own right, but we're also concerned with how these metrics translate into better or worse user experience, depending on the conditions. So at HeadSpin, we support running tests from a bunch of different targets. So each target can spawn up to 200 threads or 200 agents. This is really an upper bound because it kind of depends on the location of the different targets. It depends on, you know, various factors, like if the target is in a remote location that has spotty internet, for example, then maybe it won't scale fully to 200 just because the internet connection is already dodgy. But basically, anywhere that we have P boxes, anywhere and more locations even, we can actually spawn a target. So basically, the way you scale the load test from a HeadSpin perspective is you specify multiple targets, and then you set each target to run so many agents, and then you basically multiply the two, and that's sort of the expected throughput. We also support running the tests on a regular basis, scheduling them, so you can like set a cron tab type format if you want to schedule it continuously. I mean, of course, you can manually start the test too. That's what we'll do for the demo. And then we're working on integrating this with our performance monitoring UI. So to actually run a load test with HeadSpin, the biggest step is to actually create a playbook. And the playbook is in HeadSpin, it's a YAML file. It supports the YAML format. And it has different parameters that let you specify the targets, the agent count, the duration, even the cron tab format, the cron tab schedule, the performance task ID, and some other factors like that. We'll discuss the playbook in more detail in a moment. And then basically you upload this playbook and then you execute the test. And there's a UI to do that. And of course, HeadSpin, we can also help with that process as it goes along. So a sample playbook kind of looks like this. As I was saying before, you can notice here we have this duration field, we have this ramp up, ramp down field. These indicate, so the ramp up, ramp down indicates how long it takes to ramp up the test case to the full agent count, and ramp down is how long it takes to ramp down from the full agent count back to 0. These are approximations because, especially ramp down, because if you have an agent that's misbehaving or maybe your server is stalling for a long time, there's various timeouts that can take effect. So sometimes the ramp down time is actually a little bit longer. But the duration is the actual length of the test, what we call the saturation region, where the full load is on all maximum number of agents, give or take, various oddities for the full time. That's in the duration. And then you can specify, again, the frequency here. You can specify the perf task ID, which is if you wanted to integrate this with their performance monitoring UI. We'll discuss that a little bit in the demo. And then you specify a list of targets. And then on the other side, you have the agent specs. And this is sort of the meat of the playbook. This is the part of the playbook that indicates what to actually do, what scripts to actually run. And the contents of this agent specs are a list. This is YAML syntax for a list. So it's actually a list of scripts that you can run. And each script has a name. That's what this about field is. It has a relative weight. And then it has the script itself, which has the different commands to run. The relative weight sort of indicates, if one has a relative weight of 2 and another has a relative weight of 1, the one that has a relative weight of 2 is going to run twice as often. And then we have the actual script itself, and then we have different commands. We'll talk about that in a moment. These slides kind of summarize what I talked about there. I'll note in passing that in the sample playbook, we really only show like HTTP request, but we also support WebSockets. So you can imagine instead of making an HTTP request, you connect to a WebSocket, and then while the WebSocket is open throughout the duration, you can send data. You can receive then send, which is sort of a asynchronous way of thinking about it, right? When you receive a WebSocket request and then respond in response, or send a request in response to the previous request. We support that as well. We also support match expressions. So in the command above, or in the sample playbook, let me go back to that slide really quick. There's this match field. This generates a special event if you match if you match whatever content is here. So you can envision, a basic example of a match expression would be like a regex or a regular expression, right? Something like this, where you're just matching some regex and then you match some data, and if it matches, you generate an event, right? But we also, so we support regular expressions, but we also support this JMeter path, which is a JSON selector syntax. This is sort of our observation that a lot of APIs have a JSON-based format, so it sometimes is easier to reason about, like using a JMeter type selector. So like an example of this selector would be if key.nested would be the selector, then that would select thing from this sample JSON here in data. The full spec and the full specification is sort of here at this URL for more detail. And we support, so like HTTP request, you can generate a match expression based on this. You want to match some input. Let's totally hypothetical URL, but you want to match this expression. And then you can also specify should match, which means like in addition to selecting whatever it was supposed to, you want it to actually match whatever this value is directly. So we support that. All right, so let's go into the demo. Let's see here. So for the purposes of the demo, I wrote a very simple Flask application that was intentionally designed poorly. So in this application, we have a basic index.html. It's a basic web page. It has a basic image file. The image file is around 2 megabytes. And then we have this API call, which intentionally has this time.sleep. In reality, you wouldn't have this time.sleep, right? Most servers would have, they would actually be doing some form of computation, but this is to sort of simulate the case if the server was bogged down for some reason. And so we have we have a very simple test server, and let me spawn it up over here. Okay, so to show you, all right, so this is it's extremely dumb, extremely simple, and it has a basic UI. You can see that the server is being hit when we make these requests, right? So, you know, and then if you click, you sort of have this delayed API call. So you can already see that the performance can potentially, when you start making multiple API calls, that it kind of lags a little bit. So we can see just ad hoc playing with this is a stupid example again, that it's kind of slow, that the server is bogged down in some sense. We can actually, let's see here, we can actually simulate this by running this on a device. So just because, let's record a basic session that hits this same server on our mobile device. Okay, so it loaded. We'll do a new incognito window just to make sure no caching or anything. Okay, and you see that the phone renders the same thing, but the phone takes a little bit longer, probably because it has a different form factor. This website was, again, very, very simple, so the phone had to resize the image to even fit. It's kind of hard to see because we'd have to zoom in a little bit to see, but it's basically the same as you'd expect. It behaves the same way as the desktop application. So we'll stop recording the session and we'll view. So if you notice in this session application, if in this recorded session, we can see the metrics generated. We can see that there was a slow download, which is probably the image file. We had some duplicate messages. This is probably, again, the image file because we refreshed and we didn't properly cache. You can see that the server was slow, and there's various other exceptions. So if you look right here, you can see there was for this particular request, these are the 2 button clicks, the 2 API calls. They took about a second and some change, which makes sense because we had a time.wait call in our server, which was going to stall for a second. So now we want to see how this performs under load. Let me actually do something really quick. I'm going to add this to the user flow, just so we can keep track of the session for later. Okay. Now, we want to test this server with the bigger load. So I wrote this script right here, demo SSL, that basically runs various commands that you'd expect. So it connects to the server, it loads the dog image, and then we also hit this route, does not exist, just to see if it catches error codes correctly. And then every so often, we'll also run the script. Instead of running the basic usage, we'll actually call this slow call. And we'll do that inside our script. So I set these fields here so that it actually uploads this directly to the performance task. If you don't set this field, we at HeadSpin can also upload the performance task. It's not an issue, but this makes it easier for the short term. So if you go to the load test UI, you see this. We will upload our playbook, which is right here. We can validate it to make sure it's valid, and then we can just upload it directly by clicking upload, and then it'll say successfully uploaded playbook. So now, make sure the server's still running. Now let's run it. So you see over here that we have one IP. The current target was in Mountain View, so that's in the United States. So you can see that this over here is toggling. It says it's generating a lot of events. It's generating a bunch of events. So if we scroll down here, we can see the events generating. Let me close this really quick. There we go. And you can see as our application scales upward, you can see that our mean HTTP send time is actually increasing from our load. This is expected because, again, our server is not very optimized. So I think the playbook right now is going to run for 5 minutes. So while we're running this load test, we're also going to run, we'll run the session in this app again. So just to make sure everything's on a clean slate, we're going to new incognito window. Let's close this other tab. And then, whoops. Actually, I'll start it from completely from scratch. This time we'll record another session. Same device, same everything. We'll go here. And now we'll visit the same application that we did before. And now we can see that it's a little bit slower than it was last time, which is sort of what we expect. We'll click this twice, like we did before. The clicking is seriously lagged. You can kind of tell that, again, it's behaving really slowly. And then we'll stop recording this session, and we'll view it. And this time, we have the same problems from before, but this time our wait massively increased. Now it's 6.5 seconds versus the 1, maybe 2 seconds it was before. So we can see that this correlates that our server is loading slower, or the server loading slower is affecting the user experience, because now this request is taking a full 6 seconds to respond. And we can see based on, a little slow here, that it takes longer to actually render the page. And so I'm going to add this again to the same user flow we did before for comparison. Let's say it passed. And now let's go view it. So we see that there was an increase from all the issues that we had. There was a slight increase in time. But if we look at specifically the wait time, the average wait, we can see that there was a massive difference. There's it's more than twice what it was before. I think our load test is still running. We can stop it early, so I'm going to do that. Let's see if it's slowly dying down there. Okay. So this time the test stopped. And now, when we go back here, whoops, I did that wrong. There we go. Oops. It's still, I think it's still uploading the load test from before. Give me a brief moment. Maybe I have to let it run all the way through. Let's see here. So the other thing we can do is we can view previous sessions. I'll demo that right now. So you can see kind of all the data from before. You can see that our time spiked right here. You can see that you can see all these different stats, and then you can actually replay it. So we'll do, like, if you click this times 10, it'll actually like play it kind of in real time, like so. And then of course, if you want to just cut it out early, like we will here. Okay, let's see if this, let's run this load test again. Curious why it's not. Oops. Let's see here. Not sure why it's not rendering that. Oops. Let's go render this one. Oh. Refresh the page, maybe that's, okay, there we go. There we go. So we'll let this load test continue running. Oh, there, okay, there it goes. Sorry about that, it just took a little time to load in. So if you notice, the first time we ran this, this is our first device, this Nexus 6P device, and we ran it in Mountain View. We'll do the total wait time because that's the average wait, because that's the one that we noticed when we were doing the session UI, we saw the difference. So you see that this is the test here before we ran the load test, and this is afterwards. But we also collect information about the load test itself so that we can see, we can actually reference this time. Whoops, sorry, click that. And it's a special load test device because it's not a real device. It's kind of a placeholder because it's not a real device. So the load test started around here. This is where the load test started. And when this other load test that we're running in the background completes, it's going to add another dot to the test here. But you can see that before when the load test started around here. And so when you look at this device and look at any of these other metrics, again, we'll choose the average wait time because that's what we care about. You'll see that after the load test had started, the performance was a lot worse. And so here at HeadSpin, that's kind of why we are interested in load testing, because we can equate these different, we can equate stressing the server with this load. We can equate that to actual user performance. Okay, let's go back to the slideshow. Okay, and these slides kind of summarize what we did. So when we run a second load test, more points would appear from each load test. Once our current load test running, let's see how much more time. So in about probably 4 minutes, because it took a while apparently for it to actually upload the results. But so maybe in 4 minutes there would be another dot from our second load test. Yeah. So are there any questions? Okay, thank you. That wraps this up.
Thank you.